All right, so now that we've learned about free body diagrams and we understand the various types of forces, we want to be able to create these free body diagrams to help us analyze whether or not the object has an acceleration, but ultimately we're going to be doing math with this. So what we want to do next is learn how to put values on those force vectors so that we can then do some math and figure out what force is actually causing that object to accelerate. So in the previous lesson, we said that we're going to draw free body diagrams and we're going to label our different types of forces. Now that we have created those free body diagrams, we are going to put numbers on our force diagram, and then we are going to use our vector addition that we learned in the previous two chapters to figure out what those net force values are. We're going to either calculate vertical or horizontal net force. So these two things are going to be independent of each other. Just pick one at a time anyway. Pick one at a time to evaluate whether or not there is a net force or what that net force value is. Now, once again, we talked about balanced and unbalanced forces and what that means. So now we're going to go back to that balanced and unbalanced, and we're going to talk about what that means with numbers attached. So let's go back to a previous example. Let's just use our first one. If we have an object that is experiencing a gravitational force downward, and let's say that this has a value of 10 newtons, and it experiences a normal force upward, which is also 10 newtons, because we see here that they are marked as being the same magnitude. Now we are going to do our net force calculation with this. Basically, we're going to do vector addition, where we said that up is positive, down is negative, right is positive, left is negative. And then remember that we also have forward as our positive direction and backwards as our negative direction. So some of these questions are not going to tell you right, left, but from the situation, you should understand if that's forward or backwards, and then we'll assign positive negatives from there. So here we have a net force that needs to be calculated, where the upward direction is a positive value and the downward direction is a negative value. So the way that we're going to calculate our net force is by saying our net force is the sum of the forces, where we're going to take F1 plus F2. Now, in the example that I just gave you, F1 was a positive 10 newtons, and F2, because it's downward, was a negative 10 newtons. So if I'm going to use my net force equation, I am going to say Fnet is equal to my first force is a positive 10 newtons. My second force is a negative 10 newtons. So if I add that up, I get a value of 0 newtons. Now what does that mean? That means that the forces are balanced, so the object is not accelerating because essentially there are 0 newtons acting on the object. Even though there are forces being applied to the object, those forces are completely canceling each other out. So it's as if there's no force acting on the object, no acceleration, okay? Now we have some new vocabulary. We have the word equilibrium, and equilibrium is just a new, fancier way for us to say balanced forces. So what does that mean? That means that the sum of the forces equals 0. If we have equilibrium, we have balanced forces, we have no acceleration, so the object has a net force of 0, and it does not change its motion, okay? So all forces add up to 0, and that means there is no acceleration. Remember, in order for this net force equation to work, we have to assign positive and negative values. So if we were to look at the book on the table that is accelerating, here we have unbalanced forces. We're balanced vertically, but horizontally they are not the same. So if I knew what these force values were, let's say that this was 15 newtons and this was 3 newtons, then I would calculate my net force F1 plus F2, where in this case, F1 would be my negative 3 newtons plus F2 would be my positive 15 newtons. So what is the net force acting on the object? Well, 15 minus 3, or negative 3 plus 15, however you want to go about that. That is going to give me a positive value of 12 newtons. Remember when we talked about vector addition, we said that this should be connected nose to tail. So these two vectors are actually canceling each other out, where this is the magnitude of the result of these two forces. So this represents my net force, which is 12 newtons. In future questions, we'll be using that information to then answer acceleration questions and a few other things, but this is the gist behind net force.